prior to colliding, two blocks with masses m1 of 1.5 kilograms, m2 of 4.5 kilograms, move toward each other on a horizontal, frictionless surface with speeds v1 and v2 that are 6 and 1.5 respectively. The collision is completely inelastic as opposed to elastic. So right here, inelastic as opposed to elastic. Elastic, the mnemonic that I use is the E stands for energy kinetic, which means a conservation of kinetic energy for an elastic collision. Inelastic means that kinetic energy is not conserved. And specifically, when they say the completely inelastic, that means that two things come together, they hit each other, and then one blob moves off. So there is no bouncing away from each other. And afterward, the two blocks are joined together. Okay, so this part right there is not needed. It's just redundant because they said completely over here. Completely and joined together, that actually ends up meaning the same thing. But it's nice that they mentioned both of them because minimizes confusion, reduces human performance traps. Okay, so now that we got the basic setup here, after the collision, the two blocks move in the negative x direction, move in the positive x direction, are stationary. So I'm just going to find the resultant velocity because we're probably going to have to use it anyway. That's just how these problems tend to unfold. So momentum 1 plus momentum 2 equals momentum 1, 2. Momentum is mass times velocity. Oh, I guess I should have vectors up there. I should. Actually, very much should have vectors up there. So then we have mass v1 plus mass v2 equals mass 2, 1, 1, 2, velocity 1, 2. And that 1, 2 just means they're combined. So for the mass, that's pretty straightforward. It's just mass 1 plus mass 2. Okay. Solving this out then for v1, 2, we have velocity 1, 2 equals mass 1 v1. I'm going to leave off the vectors for now. But we know they're still there. Mass 2 v2 all over mass 1 plus mass 2. So mass 1 times v1 is 1.5 times 6. So 1.5 times 6 plus 4.5 times 1.5. 4.5 times 1.5. And then we're going to divide by the combined masses, which I think is 1.5 plus 4.5, which will give us 6. 1.5 plus 4.5 equals, one thing, this is the danger of me leaving out the vectors. This velocity is negative 1.5. So if I do it like this, actually make these vectors, they're going in the opposite directions. So that needs to be taken into account through the negative sign. Okay. Yep, calculator. On, clear, 1.5 times 6 minus, I'm just going to move the negative sign out, 4.5 times 1.5, enter, divided by quantity, 1.5 plus 4.5, which I could just call 6, but I did not, gives us 0.375. And specifically, this answer is positive. Positive implying a positive x direction. Actually, positive implying it's the same direction as v1. And v1, that's excessive. v1 is moving in the positive x direction, so yes, it is in the positive x direction. But to be technically correct, this positive number means it's the same sign. This number has the same sign as v1 did, so it means it's moving in the same direction as v1. So they could get really tricky and put v1 going in the negative direction, then you have to deal with all that. But just keep that in mind that positive numbers do not always automatically mean positive x direction. Okay, the ratio of the total kinetic energy to the total final kinetic energy, Ki over Kf, is, so energy kinetic, I like to write it like this. It's a very, I guess, European way of doing it, where you have the adjective after the noun. But it works, 1/2 mv squared, and it helps me that way. And also I think it looks nicer when you have like energy potential. That's like, oh, they're both energies, they're just different subsets. I like it, personal preference. You can do what you like. Okay, so we're going to have energy kinetic initial will be 1/2, I'm going to call this initial for I, 1/2 m1v1 squared plus 1/2 m2v2 squared. Energy kinetic final, I'll write that as 1/2 m12v12, which we just found, squared. This will be some calculator action. So we'll take our calculator, click. I don't need that up there. I got that written down. So do 2.5. I'm going to do a parentheses here. I know I'm courting danger. 1.5 times 6 squared, which I'm just going to write as 36. I know. Probably going to get myself in trouble by missing something. 4.5 times 1.5 squared. And I think that's going to be 2.25, but I'm not going to risk it. And then the 1/2 is capturing the parentheses. So we have 32.0625, 32.0625, and that's probably in joules because this is in kilograms and meters per second. Both are SI units. Okay, so, and joules an SI unit. Now we're going to do the second part. So we have 0.5 times the combined masses, which is 1.5. 1.5 plus 4.5, which I'm just going to do is 6 times, 6 times, and then the 0.375 squared. Okay, so just to show you what I did here, 1/2 mv squared. V squared is the velocity squared of the resultant blob, and 6 is 1.5 plus 4.5. And we get 0.42, I'm just going to do divided by 32.0625. So this number divided by that number. That's probably not what I wanted. I wanted to do the inverse of that. So I'll do 1/2 answer. There you go, 76. So I'm going to write this down, 0.42, and then 32 divided by 0.42 is about 76. I think that's one of our possible answers. Yep. Initial kinetic energy over kinetic final. Now, if this was an elastic collision, then this would just be 1, because the initial and final would be the same. So, but it's not. You have a lot of energy that's lost due to deformation, heat, sound, etc. Which of the following best describes V star, or maybe asterisk? I guess star and asterisk are the same. Aster, star. The velocity of the two blocks in the center of mass reference frame after the collision. All right, so basically the blocks hit, and then we're doing a reference frame where the key parts of a reference frame is you have basically an origin, and it can move as you're basically as you're looking at it. So basically, so we have M1, which is like 1.5, M2, which is 4.5, which is bigger. So the center of mass will probably be here. So it's also going to be moving in this direction. We know it's going to be moving in that direction at 0.375. So it's kind of like you have a camera right here that's then moving slowly to the right. And what that'll do then is that would make this one look like it's starting off slower. This one's starting off faster because you have opposite motion. But then after they hit, it's asking, how is this blob here going to keep pace with this basically camera that's moving at 0.375 to the right, I guess. Right. And the answer is, here, I'm going to look this up on Wikipedia real quick. Whoop. Wikipedia. Scroll down slightly. We're going to do center of mass. Center of mass frame. This is talking about the reference frame of center of mass. So in physics, center of mass frame, system that is unique up to velocity of an origin, blah, 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 blah. Special case in the center of momentum frame is the center of mass frame. So the center of mass frame is just is the center of momentum with an extra added on. And I think it went on to mention that it was basically centered at the origin, which, okay, this is not talking about position here. This is talking about velocity. So they could have said center of momentum frame, and that would not have changed this question, because center of mass versus center of momentum is just where the origin is. Not a big deal. So, long story short, which the following best describes if you start the velocity of two blocks in the center of mass reference frame, which has to do with momentum, it's going to be 0. It's going to be the same, because after these two blocks hit, the camera is going to be moving along at 0.375 relative to what we're seeing here. These two blocks are going to be moving to the right at 0.375. They're going to both be moving in the same direction, so to us it'll look as if they are not moving at all. So the velocity relative to, what's the velocity of two blocks? So the velocity in the reference frame will be 0. So that's kind of an obscure concept, but it's good to kind of understand it. It's one of those things where the question is so easy that they have to ask it in a complicated way just to make it challenging. Okay, hope that helped. I will see you next time.